This guy's a little bit outside the box. You guys are supposed to figure out, based on the graph, which one has a negative discriminant. What's been kind of alluded to, but not necessarily said in class, is that the number of x-intercepts that a graph has kind of implies the number of solutions that that quadratic would have. For example, if you solved an equation like x squared minus x minus 3 equals 0, and you knew that this had two solutions, I'm not saying that it does, I'm saying if that happened, and it did, then it would be the case that the graph of y equals x squared minus x minus 3 would have two x-intercepts. There's a connection there. So when we're looking for the graph of the quadratic that has a negative discriminant, what you should know from our coursework is negative discriminant means no real solutions, which would correspond, based off the information down here, to no x-intercepts. So at the end of it all, I look at these three graphs. This graph doesn't cross the x-axis at all, so it has no x-intercepts. So this quadratic, if I were to set it equal to 0 and solve it, would have no solutions. This would correspond to a graph that has two solutions, so it would have a positive discriminant, and this would correspond to an equation that has just one solution, so it would have a discriminant of 0. So as long as you can keep in mind that the number of solutions to a quadratic corresponds to the number of x-intercepts of the graph, and you know that for discriminants, negative discriminant has no solutions, positive discriminant has two solutions, and a discriminant equal to 0 has one solution, this should be no problem to answer. But it is going to require that you think about it maybe for a little bit. So let me know if you have questions. Good luck.